On a beach, on a full moon night, it's hard for me to escape the wonder of nature. And I can even see the world with the eyes of that little girl I once was, when everything was a cause for wonder. That state is not very different from the one our ancestors experienced, when trying to make sense of that overwhelming environment. Obviously, the ultimate meaning of that universe in which they lived would always be out of reach, but maybe they could decipher some small clues just by paying attention. Let's try to reproduce that extraordinary moment of discovery. What do I see in this place? What catches my eye? Undoubtedly, the moon that illuminates the scene. And it is reasonable to assume that along with the beach on which I stand and the rocks, it is made of solid material. Instead, the sea, with its gentle waves, is basically water and, therefore, it is a liquid. And the wind is nothing more than the movement of the same element that I breathe. It is air that is neither solid nor liquid. It's a gas. And so, the matter that makes up nature, in all its variety, is presented to me in three possible states: solid, liquid, and gas. This idea was reached by all civilizations in all corners of the planet, many years ago. And they also realized that any material could change from one state to another. The best known case is that of water. In general, we find it in liquid form. But if it is very cold, it becomes ice, that is, it becomes solid. And if we heat it, it transforms into steam. This transience of water is so well known that in the 18th century it began to be used to define the temperature scale, assigning the 0 degree to the freezing temperature of water, and 100 degrees to its boiling temperature. But water is not unique in having these characteristics. For example, of the elements we discovered on the night beach, the sand liquefies above 1,577 degrees. And so, 3,500 years ago, humanity learned to make glass. Obviously, it took us many more years to discover that air can also change its state. On a commemorative plaque at the Jagiellonian University in Krakow we can read that, in this building Karol Olszewski and Zygmunt Wróblewski, in 1883 liquefied the air for the first time. If it had not been achieved before, it was due to the extremely low temperatures that had to be reached. Air becomes liquid below -194 degrees and solid below -215 degrees. You've probably heard the phrase that water boils at 100 degrees at sea level. This is because the boiling temperature varies with the atmospheric pressure, and this decreases with height. For example, on Mount Everest, at almost 9,000 meters high, the atmospheric pressure drops to a third, and the water boils at 86 degrees. And if we climb even higher, to 19,000 meters, the pressure is 10 times lower, and the water boils at 37 degrees, which is the temperature of the human body. That our bodies can spontaneously boil is not something we would want to experience in person. If we increase the pressure, the process is reversed, and the boiling temperature increases. For example, if we subject the water to a pressure 10 times higher than that of sea level, the water remains liquid up to 180 degrees. Titan, Saturn's largest moon, is at a pressure 50% higher than Earth's and at 180 degrees below zero, which is the freezing temperature of methane. Therefore, on Titan there are clouds, storms, rains, rivers, and seas, but not of water, but of methane. And its surface has a huge concentration of ice rocks, permanently frozen. Scientists were satisfied with this knowledge of the three states of matter and how one can move from one to the other, just by changing the pressure and temperature. However, in 1928 the American physicist Irving Langmuir began to systematically study a new state of matter that turned out to be, with more than 99%, the most abundant form in the universe. We will return to this fourth state of matter in another class. Until then.